Okay, so for week one, we are going to be covering chapters 1 and 2. Our textbook defines statistics as the study of how to best collect, analyze, and draw conclusions from the data. And so when we're thinking about statistics, I always think of statistics as being about using data to try to answer a question about the world. And when I'm doing that, there's some largest group called the population that I'm interested in. And sometimes the population is people, like all people living in the United States. But sometimes the population might be things also, like all nursing homes in the state of Vermont. Oftentimes, populations are too large and it's too difficult for us to collect data from the entire population. So instead, we'll use data from just a sample, a subset of the population. So it's going to be important to think about how to best collect that data and how to choose that sample. Once we have the sample, we're going to be able to use the data and analyze it, and then try to use what we learned in the sample to make inferences about what we believe might be true in the population. So this is the basic idea behind statistics and what we're going to be working towards throughout the semester. Now in chapter 1, we're going to see 4 sections. The first one is a case study about using stents to prevent strokes. This section is used to provide some motivation. Get us to think about how we can try to use data to answer a question about the world. What would be an appropriate way to summarize the data? How can we be sure that the data that we observed is representative of the world beyond the sample? And if I see that there's a relationship between 2 variables, how do I know if it's cause and effect? Right, so these are some of the things that we're going to be motivating in this first section. Section 1.2 is called Data Basics. In that section, we'll start with picking up some vocabulary so that we can all learn how to talk about data using a common language. After that, we'll talk about variable types. We'll distinguish between categorical variables and numerical variables. There are other subtypes within each of those two, but those are the most important distinctions. So that's what we're going to focus primarily on, is categorical versus numerical variables. That's going to be an important theme throughout the course, because whether we're dealing with a categorical variable or a numerical variable, it's going to affect how we summarize it and display information about it and analyze the data. So that's going to be a really important piece. We're going to start looking at how we can think about whether 2 variables are associated with each other or independent of each other. When we're considering relationships between 2 variables, we'll be able to think about which one we think is the explanatory and which is the response variable. And generally, it's the explanatory variable is the one we think might possibly be influencing the response variable, and we'll see more about that as you work through the material. We'll also note that just because 2 variables are associated with each other doesn't necessarily mean that there's a cause and effect relationship between them. And we'll distinguish between observational studies, which give less strength to claims of causation, and experiments, which can often give more evidence that there's actually causation and not just an association. So we'll be looking at those things in section 1.2 and continuing to look at them later. In section 1.3, you'll focus on sampling principles and strategies. We'll learn to distinguish between the population that we're really interested in and the sample from which we actually collect data. And then we know that if we're trying to use a sample to learn about some larger population, that we want to be careful to make sure we select a sample in a way that's going to be representative of that population. And we'll learn about 4 different sampling strategies that are sometimes used to choose the sample. Then that section will also focus on why observational studies can make it difficult to establish causation. Section 1.4 focuses entirely on experiments. Let's start by learning about 4 key principles of experimental design that we'd like to have to know that we have a good experiment. We'll see that random assignment to treatment groups as part of an experiment allows the researcher to make stronger conclusions about an association actually being causation. In Chapter 2, we're going to focus on summarizing data. Section 2.1 focuses on how to summarize numerical data. And it briefly talks about how to look for an association between 2 numerical variables using something called a scatter plot. And then goes on to talk about how to summarize a single numerical variable. And the things that we like to think about when we're summarizing a numerical variable are where the center of that distribution is, which we measure by the mean or the median, the shape of the distribution, which we're going to judge from graphs, and we'll see 3 different types of graphs that we're going to use to look at the distribution of a single numerical variable, a dot plot, a histogram, and a box plot. We'll also want to have a sense of how much variation there is around the center, and we'll see ways to measure spread or variation using variance, standard deviation, and the interquartile range. And then we'll talk about these summary measures. Some of them are strongly affected by the shape of the distribution or by having outliers. And some of them are not so strongly affected. And so we'll look and see which ones are more robust and which ones are strongly affected by outliers and skew, and think about how that might influence the choice of which summary measures we want to use to describe the distribution of a numerical variable. In section 2.2, we'll learn about how to summarize categorical data. Categorical data is often summarized using tables called contingency tables, and we'll look at how those work. Also, we'll take a look at bar plots, which I'm sure many of you have seen, probably all of you have seen before. And we'll also look at something called mosaic plots, which can be useful if we're looking for a relationship between 2 categorical variables. And then finally, section 2.3 works through a case study looking at evaluating the efficacy of a malaria vaccine. There'll be a brief discussion of the study design, and then they'll look at how to summarize the sample data, how to measure the observed difference in the infection rates with malaria between the vaccine group and the group who received a placebo. And then how to start evaluating whether we think that difference may have been due to random chance, or if we think that the malaria vaccine is in fact really effective. And so that piece is going to start bridging us into this idea that randomness is an important part of working with sample data, and being able to think about how likely different things are to happen is going to be an important way of evaluating the sample data. And that will bring us into Chapter 3, which will start next week, which will focus on probability. So that's just a little sort of introduction to the basic idea of what we're going to be focusing on this week. The videos for each of the sections are linked in the My Open Math, so you can watch those there. Please don't hesitate to ask any questions. Have a good day.